Don't forget to subscribe and ring that bell.
We are back for the final part of the Algebra 2 Cliff Notes. I think we ended off with series and sequences, so we're going to pick up just after that, and we're going to finish this up. Let's go. All right, I just want to briefly talk about growth and decay in the parts of an equation. All right, so first of all, the equation is set equal to an amount here. That's going to be your end amount. All right, whatever your equation is equal to is your end amount. All right, this number that's in front of the parentheses is your beginning amount. Okay, I call that P. You can call it anything you want. I have A here. Note that this is going to tell you whether it's growth or decay. If it is more than the number 1, so if you're adding something to 1, that's growth. If 1 plus r, there you go. I know it says if 1 plus r is less than 1. I always do plus, but if it's decay, if it's less than the number 1, it's technically 1 minus your rate. But you can do 1 plus a negative r. Okay, so it doesn't matter. But if what's in parentheses, again, right here, if it's more than 1, it's growth. If that value is less than 1, it's decay. Right? And last but not least, that's, I guess I should make a note here. The R value, whatever you're adding or subtracting, that's actually your rate. Okay? And we don't want to put that percent in the formula. We want that in decimal format. We don't want the percent sign there. And last but not least is this t here, and t is some unit of time. All right, so they'll give you, out of those 4 things that I have highlighted there, in the blue, green, purple, and yellow, they'll give you 3 of the 4. Okay, and you got to figure out the 4th one. And it's not that difficult. All right, exponential equations. I like to use the natural log no matter what I'm doing, but let's just go over the same base. Um, Again, I would really just use natural log. The same base would have, you need to recognize that I can write 16 and 64 in the same base, meaning 16 is really 4 squared, isn't it? Well, if this 16 is raised to the power of x, this value, 4 squared, which is also 16, is also to the power of x. I can write 64 is 4 cubed, right? Now, if I have an exponent raised to an exponent, you should know your exponent rules. I multiply them together. So it's 4, and the exponent is 2 times x, which is 2x, equals, this has not changed. Once I have the same bases and they're equal, if the bases are the same, the exponents have to be the same. So I'm just going to cross the base out and set my exponents equal to each other. Now I can solve for x. All right, the last step here is I just divide by 2. Divide by 2. So x is 3 over 2, or 1.5. However you want to write that. Okay? Now, I said I like using natural log. And I like to use natural log over log because I just like to use natural log for everything. But I'm now going to use natural log, and I'm going to solve the same problem here. We know what the answer should be, okay? So if I have 16 to the x equals 64, all right? As soon as I get my base and exponent alone, okay, I can now take the natural log of both sides. If I take the natural log of one side, I have to take the natural log of the other. What log and natural log do is it brings the exponent down like it's a lead coefficient. X times the ln of 16 equals the ln of 64. Okay, now it's a million times easier to solve. I'm just going to divide both sides by the natural log of 16. This goes bye-bye, and I have my x equals. I'll just put this right in the calculator. Do not cancel natural logs. Those are actually operations, like a plus sign. I can't just cancel plus signs, okay? So don't try and cancel natural logs. I'm literally, quite literally, going to take, all right, alpha y equals, I'm going to create the fraction, why not? Natural log button is right next to the number 4. It says ln of 64, close that parenthesis, over the ln of 16. And there it is, 1.5. 1.5, which is the same thing as 3 over 2, which is the same exact thing as we got over here. Should be the same thing. It's the same flipping problem. But I like to use natural log. I like to bring that exponent down. It's easier. It saves you from trying to find a common base for some complicated numbers. And speaking of natural log, okay, we're going to solve that x over 2. This thing right here, don't be confused because it looks bigger. This is an exponent. So what I'm going to do is I need to get my base, e, and my exponent alone. The 2 is not part of the exponent. It's not connected. If it were, you'd have parentheses here. Okay? But we don't have that. So we need to get that e raised to the x over 2 alone. So the first thing I'm going to do is just subtract 7 from both sides. Boom. Negative 2 times e to the x over 2 equals 1 minus 7 is negative 6. Right? The next step now is I'm going to divide by that negative 2. I want that gone. So I've got e to the x over 2 equals negative 6 divided by negative 2. Well, that's a positive 3. We're looking good. Natural log to bring the exponent down. I can't even do the common base. I can't do the same base or common base here. That's why I always go to natural log. All right? So if I take the natural log of both sides, all right, not only will this exponent come down, but natural log and e cancel. What do I mean? So I have x over 2. This technically goes bye-bye, and it equals the ln of 3. All right? How does it go bye-bye? Well, if the exponent comes down, like the previous problem, you see how the exponent came down the x, and I multiplied it times the ln of 16? Well, I'm technically multiplying it times the ln of e. But here's a little secret, kids. The ln of e equals 1. So what happens if I multiply anything times 1? It's itself. Okay? It's itself. So let me write this a little bit closer. X over 2, and we'll get rid of this. All right. Now, I still don't have my x alone. Some people like to do this ln of 3 right now and get a number, and you can do that. I like to wait till the end. I know at this point, if I multiply this by 2, I got to multiply this side by 2 as well. So now x equals 2 times the ln of 3. And this is what I'm going to put in the calculator. All right? Don't try and do ln on your own. You can't do it unless it's e. Or the ln of 1 is 0, but let's not go there. 2 times the ln of 3. We will go 3 decimal places right here. That 7 will stay a 7 because the number after it is a 2. So we have 2.197. God, that's good to do some good math. Good. That's really all the stuff that's important that I wanted to go over for Chapter 4. And Chapter 5, or Unit 5, is statistics. And since we kind of just ended the year in this, it's really just more of an explanation. I think there's only really one problem to do at the end. But I digress. Here we go. Probability. First of all, whenever you're going to get a probability, you're going to create a fraction. In the top, or the numerator, is going to be the number of desired outcomes. Okay? And the bottom is going to be the number of total possible outcomes. So, I don't know, for poops and giggles, let's say I had a die. Let's make this realistic and do this in black. Not that I can really draw at all. Okay, 1, 2, 3, and so forth. Okay, now one dice, which is called a die, which I can't stand, but okay, if I roll this die and I want a number, this is what I want, that's less than 3. That means either the number 1 or 2. Okay, these are my desired outcomes. I have 2 possible outcomes on the top. How many total outcomes are there? 1, 2, 3, 4, 5, or 6. I can get any one of those. Those are the total number of outcomes, but I only want the numbers that are less than 3. 2 out of my 6. Okay, or in decimal, that's 0.33. Or you would say you have a 33% chance. All right, probability, percent, fraction. I don't, whatever. Okay, so if they say P of A, okay, or P of anything, that's really saying the probability of the event A happening. If they say P of A, and they have this little kind of upside down horseshoe, that means and. The probability of both A and B happening. So the probability of A and B happening, you have to know the probability of A and the probability of B, and you need to multiply them together. Or if you have a table, you can just look it up in the table. If they have this little U in between, that means either A or B happens. Okay? They both don't have to happen. So how do I get that? The probability of A or B means I still take the probability of A, and this, my friends, oh, you're supposed to add these. This is supposed to be a plus sign here. Ooh. You take the probability of A, add it to the probability of B, and then subtract the probability of both A and B. And let me explain why you need to subtract the duplicates, okay? Let's say I have 2 students. Well, let's say I have 3 students, okay? 3 students. And I ask them, okay, how many students play an instrument? So the probability of playing an instrument and, or in this case, I'll say or, playing a sport, okay? The probability of playing an instrument, 2 of them raise their hand, 1 and 2. Then I say, well, how many play a sport? This one plays a sport, and this one, well, I'll do that down here, plays a sport. So the one in the middle here does both, okay? So if I were to do this, how many play the instrument in red? 2 of them do. 1, 2. So that's the instrument, the probability of the instrument, which is 2. I add that to the probability of them playing sports. Again, there's 2 of them that play sports. If I don't subtract out and I just stop there, that's 4. I don't have 4 kids. There's only 3 kids. So I need to subtract out the ones who do the instrument and do the sport. There is one of them that does both. 4 minus 1 is 3, and that takes care of all 3 right there. All right, conditional probability means given, okay? If you have this little bar in between, that's the probability of A given only B to choose from. If they give you numbers, okay, we're going to use this formula here. The probability of A and B over the probability of just B. All right, whatever the one is in the back, that's going to end up being the denominator. But if they give you a table, okay, and they say here's the X's, here's the Y's, here's the A's, the B's, the C's, and they have this table and they have all these numbers, right? And they have totals. Let's say 2, 3, 4, 5, 6, 7. And we got to add all these up. This is 7 down here. This is 9. This is 11. This is 7, 8, 9. If I add them this way, I got 18. And all together, I should have, what's that, 27? All right. Now, if they say the probability of X given your C's, what this means, when you just have a table, I think it's easier. They are just giving you the C's to pick from, which means I am only looking at these 11 C's that I have here. So out of the 11 I have, how many are X's? Well, there's 4 X's out of the 11. So that's 4 over 11. I think that's easier when you have a table. I would only use this if they give you the probability of A and B, and they give you the probability of B. Like they actually give you the numbers. If they don't, if they give you a table, I would do it the table way. Independence. This is actually a common multiple choice question. Like maybe you'll get one. You won't see multiple of them. There's 2 ways you can check to see if 2 events are independent. First, it's the probability of A given B has to equal the probability of A, the first one. So if I switch them, the probability of B given A, it would have to be the probability of B, the first one. If those numbers are the same, then it is independent. Okay? If it is not the same, then it's not independent. Okay? The numbers would literally have to be the same. I would always use this first one. The only reason I would use this second one is if they give me the numbers for the probability of both A and B happening, and the probability of A happening, and the probability of B happening. If they do that, multiply these 2 numbers they give you together and see if it equals this other number that they gave you. If they're equal, it's independent. If it's not equal, it's not independent. All right. Anytime they ask you to find a percentage of values, okay, what percent of grades in your math class are between 71 and 88? Okay. Well, first of all, in order to do that, okay, they got to give you a couple of things. First of all, they've got to give you a lower and an upper bound. In my example, I said 71% to 88% average for the marking period, right? They also got to give you a mean, and they got to give you a standard deviation. In fact, how selfish of me to not use all 4 different highlighter colors. And you can do this right in the calculator by going to, you press second and vars, because above vars in blue is the distribution. Okay. And then you pick normal CDF, which is choice 2. Choice 1 is normal PDF. We want the one with the C. Okay? So, in your calculators, if I went second, vars, and I picked choice 2. Okay? And let's use that example. All the people that scored between 71 and 88 in class. And they said, let's say the average was, I don't know, 80 on the button, 80. And the standard deviation was 2.5. All right? Let's go 4.5. All right? When I go down here to hit paste, you write this down right here. This is showing work, just writing this down. And I hit enter. 93, I'd probably round that up to 94% of all scores would be between 71 and 88 if there was an average of 80 and 4.5. Remember, they're going to give you all 4 of these numbers. They're asking you for the percent. That's the probability, 0.9395. But we would call that 93.9, or maybe even 94, because the 9 would go up to, say, whatever. Okay? But writing this down is showing work. Oh, man, I hope you get a problem that involves the 95%. What is that? Well, 95% of the bell curve, of 95% of all data, If it falls within that 95%, that's considered common or a normal occurrence. 95% of all our data falls within 2 standard deviations away from the mean. So if they give me the mean, even if it's like a little font on a chart, and they give me the standard deviation, you can calculate your 95% confidence. You can calculate everything that falls within normal averages. Okay? Or it's normal. So I've got this example here. Visca says it's completely normal for students to score a 78 on the final exam. After years of students taking the exam, Visca found that the mean of the exams was 66 and the standard deviation was 7%. Was Visca correct? Use statistical data to support your answer. Okay. In order to find my 95% interval, I take my mean, which is 66, and I add and subtract 2 times my standard deviation, which is 7. That's going to give me this interval here. So 66 plus 2 times 7, 66 minus 2 times 7. All right? So, doing a calculator, although I could do it quickly, but we got 66 plus 2 times 7, and we have 66 minus 2 times 7. Okay, from 80 to 52, those scores right there. So 80 to 52. That means any score that falls in between 52 and 80 is considered a common occurrence. Do kids normally score a 78? Yeah, because it's in this interval. Do kids normally score a 90? That's not common. I bet some, a couple of kids do it, but a 90 is not common. How come? It's not in this interval. So let's look back at the problem. Visca says it's completely normal to score a 78. Is 78 in between 52 and 80? Yeah, it is. So was Visca correct by saying that this is normal? Yeah, because everything in here is normal. So use statistical data to support your answer. Ready? Let's answer it. Yes, 78% percent is normal. That's the answer. Now let's use statistical data. Okay. Since 78 falls in our 95% common interval of 52 to 80. This right here is your statistical data. Right there. That is so easy when they ask you if something is normal or not. You just got to remember that you take the mean that they give you and you need to add and subtract 2 times the standard deviation. That gives you the upper part of the interval and the lower. Everything in there. 95% of all my results are going to be in there. The 5% that aren't in there, those are abnormal results. Either they're abnormally high or abnormally low. But guess what? On this Algebra 2 test, you, my friend, are going to score abnormally high and well. Okay? You're going to be outside the 95% on the good end. All right? Look it. I could have done 12 to 50 different problems for each one of these content things, but I just wanted to explain them to you. If you want to do more, 95% interval is something normal questions, Google it, or do some old exams and try and find them on there. All right. I have YouTube videos up the yin and the yang of me doing and explaining old Algebra 2 Regents exams. All right. Good luck. You got this. We'll see you.
Don't forget to subscribe and ring that bell.